Okay, welcome to this page of the notes. What we're going to do here on this page is get an introduction now to the OR compound inequalities. Right here, let me highlight it for you. That's exactly what this box says, OR compound inequalities. So let's go ahead and talk about what this means. Again, if I go to my favorite restaurant, Five Guys, and I order a burger or fries, I don't expect to get both. I've only ordered one or the other. I'm not that hungry. I'm really only in the mood for French fries. So when I go up to pick my order and I open up my bag, I'm expecting to see only French fries, just French fries, because I asked for a burger or fries, whichever you have available right now. Give me whatever I can get the fastest. I gotta get home. So they give me French fries because that was what was available, and I asked for one or the other, and so as long as one of them is in there, I'm happy. What's going to happen with this inequalities is you only have to satisfy one of the inequalities at a time, all right? There will not be a number capable of satisfying both of the inequalities at the same time. It's either one or it's the other. It can't be both. Let's take a look at this. The first one they give you is x is everything greater than or equal to 5, which is exactly what they've done here on the number line. They have found 5. They have filled in the circle because it's greater than or equal to, and graphed everything greater than 5. Let me show you that in green. That's everybody going in this direction, which means I need all numbers that are greater than or equal to 5. Let's go ahead and put a green line coming straight down so we know I need everybody greater than 5. I need everybody going in that direction. But now I have another inequality, and the question is, or x needs to be less, strictly less than a -3. Well, let me do that one in red. What they've got for you here is everything they've graphed less than -3. It's an open circle because it's strictly less than, and you see that this is everybody going in that direction. Well, let me go ahead and draw my line coming down so that we know I need everybody less than a -3. And now I see as my final solution that what I've got is arrows going in opposite directions. There is no overlap. There is no way that you can pick a real number to satisfy both inequalities at the same time. Right? If I were to pick any number in between, like 0 or 1, it actually satisfies neither of the inequalities. Now, if I were to pick something like 10, 10 would satisfy my top inequality, but it will not satisfy the bottom inequality, and that's okay. It's an OR inequality. It will either be this one or it will be this one. So 10 works for this one, doesn't work for this one. It's okay. What if I picked a -10? Well, -10 is way down here and satisfies the inequality x is less than a -3. This one works. But does a -10 satisfy the top one? No, it doesn't, but that's okay. It's an OR inequality. I only need to satisfy one of them at a time. Now, once again, the set notation for this is going to be what we call a union. You're going to take all of the numbers in the first set. That's all of these guys up here, everybody greater than or equal to 5. You're going to take all of the numbers in the second set. That's these guys right here, everybody less than a -3. And we're going to go ahead and take the union of those two sets. That means we're going to take each of those sets of numbers, and we're going to put them together. And those are your possible solutions. Now, all of those numbers don't satisfy both inequalities. Remember, it's an OR. So the solutions in your set will only be a solution to one of the inequalities, not both. But that's okay. That's why we call it a union, written out like this. Again, I will never ask you to use the set notation when writing your solution. I just want you to see it in case later on in pre-calc, college algebra, stuff like that, when you see this set notation. Again, the U for union, the E just means all of the elements. So X is all of the elements from set A, X is all of the elements from set B, and we're putting those elements together to get our solution set. So let's go ahead and give one of these a try, an OR inequality. And as I said before, what's going to happen with these is there's no real quick way to do it. With the AND inequalities, we could solve both of them at the same time. Not so here. You'll be solving the first one, you'll be solving the second one, and only one of the inequalities can be true at one time. So here we go. The first one, I need to get the k by itself. I am adding 6. Let's subtract 6 to the other side. K is going to be less than a negative 4 minus 6. So k needs to be strictly less than a negative 10. On the other side, I'm going to divide by 3. K needs to be greater than or equal to 14 thirds, which is not evenly divisible. Let's go and see what that approximates to. I got a calculator right here. 14 thirds, don't fat finger something on your calculator. It's about 4.6. Well, let's go ahead and graph both of these on a number line. Remember, we have an or right here between these. Can't be both. It's either one or the other is true at any given time. So here we go. Wow, there's a pretty big gap here. So I'm going to have minus 10, minus 11, minus 12. And then we'll do a couple here, minus 9, minus 8. We're going to skip a few. 0, 1, 2, 3, 4, and 5. All right, so here's what I need. I need to be everything less than a negative 10, strictly less than, so that means I need an open circle on 10. I need to be everything greater or equal to a negative or a positive 4.6. Guesstimate is close enough. I'm not going to go crazy about this. I'm going to say that's probably right about there-ish. Closed circle. And then let's shade our number line. I need everything greater than that positive 4.6 and everything less than that negative 10. Now, I once heard a middle schooler say that they were given this sort of visual representation of or, compound inequalities. When you graph them, picture yourself sitting in a boat here in the middle, the oars of the boat hanging off the edge, and as you row, those oars are sticking off in opposite directions. Or inequalities should always look like a set of oars coming off your boat, kind of floating here in the middle. They should always look like that. They're going to be going in opposite directions. Now, solutions. Well, all of the numbers that are strictly less than negative 10 is a solution, but it's only a solution for this one. All of the numbers greater than a 4.6 is a solution, but they'll only be solutions for this one. You can't have both being true at the same time. It's an or compound inequality. There is no way to write this in set builder notation that looks nice. So when it comes to or inequalities, you don't have to worry about it. You have just your inequalities, you have your number line, and you're all set. Takes care of all the problems on this page of the notes. Head on over to the next page. We'll try a couple more. I'll see you there.